extraordinary black hole, unlike any other, discovered in neighboring galaxy. The discovery, one of the only confirmed intermediate mass black holes, lives in an equally rare object known as a low-mass, stripped nucleus. At 100,000 solar masses, it is smaller than the black holes we have found at the centers of galaxies, but bigger than the black holes that are born when stars explode. This makes it one of the only confirmed intermediate mass black holes, an object that has long been sought by astronomers. "That's a large gap," said senior author Anil Seth, associate professor of astronomy at the University of Utah and co-author of the study. The black hole was hidden within B023G078, an enormous star cluster in our closest neighboring galaxy Andromeda. Long thought to be a globular star cluster, the researchers argue that B023G078 is instead a stripped nucleus. Stripped nuclei are remnants of small galaxies that fell into bigger ones and had their outer stars stripped away by gravitational forces. What's left behind is a tiny, dense nucleus orbiting the bigger galaxy, and at the center of that nucleus, a black hole. Previously, we found big black holes within massive, stripped nuclei that are much bigger than B023G078. We knew that there must be smaller black holes in lower mass stripped nuclei, but there's never been direct evidence, said lead author Renuka Chetty of Liverpool John Moores University, who started the research while at the U. With their new observational data from the Gemini Observatory and images from the Hubble Space Telescope, Chetty, Seth and their team calculated how mass was distributed within the object by modeling its light profile. In contrast, these stripped nuclei can have repeated formation episodes, where gas falls into the center of the galaxy and forms stars. And other star clusters can get dragged into the center by the gravitational forces of the galaxy, said Seth. So, stars in stripped nuclei will be more complicated than in globular clusters. The researchers used the object's mass distribution to predict how fast the stars should be moving at any given location within the cluster and compared it to their data. When they built a model without including a black hole, the stars at the center were too slow compared their observations. The black hole adds to the evidence that this object is a stripped nucleus. The stellar velocities we are getting gives us direct evidence that there's some kind of dark mass right at the center, said Chetty. It's very hard for globular clusters to form big black holes. The researchers are hoping to observe more stripped nuclei that may hold more intermediate mass black holes. These are an opportunity to learn more about the black hole population at the centers of low-mass galaxies, and to learn about how galaxies are built up from smaller building blocks. We know big galaxies form generally from the merging of smaller galaxies, but these stripped nuclei allow us to decipher the details of those past interactions, said Seth. Subscribe to Fourlines Journal for more such daily videos.